Ever looked up at an apple hanging from a tree and thought, why doesn't that just float away? We all have a basic understanding of gravity, that invisible force keeping our feet firmly planted on the ground. But have you ever stopped to wonder who first figured out this fundamental law of nature? We all know the name associated with gravity, the iconic image of an apple falling on his head, Sir Isaac Newton. But what if I told you the story might be a little more nuanced? What if the seeds of this groundbreaking discovery were sown long before Newton sat under that famous tree? Think about it for a moment. Humans have been observing the natural world for millennia. Ancient civilizations built massive structures, aligned with the stars, demonstrating a keen understanding of celestial mechanics, which is intrinsically linked to gravity. Farmers knew that objects fall, that rain comes down, that rivers flow downhill. These are all manifestations of the gravitational force. So, was Newton truly the first to notice this? The answer, as with many historical questions, isn't a simple yes or no. It depends on what we mean by discovered. Did someone before Newton witness an object falling? Absolutely. Did someone before him describe the phenomenon with mathematical precision and formulate a universal law explaining it? That's where Newton comes in. To understand Newton's monumental contribution, we need to appreciate the scientific landscape he inherited. Before the 17th century, the prevailing understanding of the universe was largely based on the ideas of Aristotle. He proposed that objects naturally sought their natural place, with heavier objects falling faster towards the center of the earth, while lighter elements like smoke rose towards the heavens. This was a qualitative description, based on observation but lacking a unifying mathematical framework. Then came the scientific revolution, a period of profound intellectual upheaval that emphasized observation, experimentation, and mathematical reasoning. Thinkers like Nicholas Copernicus challenged the geocentric model of the universe, proposing that the Earth revolved around the Sun. Johannes Kepler, through meticulous astronomical observations, formulated his laws of planetary motion, describing the elliptical orbits of planets and their speeds. Galileo Galilei, using the newly invented telescope, provided further evidence for the heliocentric model and conducted groundbreaking experiments on motion, including the famous, though possibly apocryphal, Leaning Tower of Pisa experiment demonstrating that objects of different masses fall at the same rate in a vacuum. These individuals laid crucial groundwork for Newton. Kepler's laws described how planets moved, but they didn't explain why. Galileo's work on falling bodies provided insights into terrestrial gravity but didn't connect it to the motion of celestial objects. They were pieces of a puzzle, waiting for someone to assemble them into a coherent picture. Now, let's return to our central question. Did anyone discover gravity before Newton in the sense of recognizing that objects fall? Yes, countless individuals throughout history observed this phenomenon. But did anyone formulate a comprehensive, mathematical law of universal gravitation that explained both the falling apple and the orbits of the planets? The answer to that is a resounding no. That was Newton's groundbreaking achievement. In his seminal work, the Principia Mathematica, published in 1687, Newton presented his law of universal gravitation. This law states that every particle in the universe attracts every other particle with a force 1 that is directly proportional to the product of their masses and inversely proportional to the square 2 of the distance between their centers. This elegant equation, F equals G asterisk, M1 asterisk M2, slash or superscript 2, 3 not only explained why objects fall to Earth but also provided the mathematical framework for understanding the motion of the moon around the Earth, the planets around the sun, and even the tides. 1. Books.google.com. Books.google.com. 2. Books.google.com. Books.google.com. 3. .kovalsci.com. .kovalsci.com. Newton's genius lay in his ability to synthesize the observations and insights of his predecessors with his own mathematical prowess. He took Kepler's laws of planetary motion and Galileo's work on falling bodies and showed that they were not separate phenomena but rather different manifestations of the same fundamental force, gravity. He provided the why behind the how. So, While people had undoubtedly witnessed gravity in action for millennia, Newton was the one who truly discovered it in the scientific sense. He provided the comprehensive theory, the mathematical language, and the unifying framework that explained this fundamental force of nature. His law of universal gravitation was a paradigm shift, revolutionizing our understanding of the cosmos and laying the foundation for much of modern physics and astronomy. It's important to acknowledge that scientific discovery is rarely a solitary endeavor. Newton himself famously said, "If I have seen further, it is by standing on the shoulders of giants." He built upon the work of those who came before him, taking their individual pieces and weaving them into a grand tapestry of understanding. Think of it like this: imagine people observing fire for centuries. They saw its warmth, its light, its destructive power. They even learned to control it to some extent. But it wasn't until the development of thermodynamics and chemistry that we truly understood what fire is, a rapid chemical reaction involving the release of heat and light. Similarly, people observed gravity, but Newton was the one who provided the scientific understanding of its underlying nature. Therefore, while it's tempting to say that people discovered gravity simply by observing falling objects, the true discovery, the formulation of a universal law explaining it mathematically, belongs to Sir Isaac Newton. He wasn't the first to see an apple fall, but he was the first to understand why it fell and to connect that phenomenon to the grand dance of the cosmos. His work transformed our understanding of the universe from a collection of seemingly disparate phenomena into a unified system governed by fundamental laws. So, the next time you see something fall, remember that while the observation is ancient, the profound understanding we have today is largely thanks to the genius of Isaac Newton. He took a common experience and elevated it to a universal principle, forever changing our perception of the world around us and the vast expanse beyond. With that said, thanks for watching, and until next time.